Hi, my name is Patrick, and I'm a graduate student in the Talapin Lab at the University of Chicago.
In our lab, we try to imagine different ways to incorporate quantum dots to make TV displays brighter and more energy efficient. For the past few decades, we have seen a rise in LCD TV technology. You probably even have one of these in your own home. LCD, or liquid crystal display TVs, use special filters to select what light comes through the screen. A liquid crystal changes the light based on the applied voltage to allow each pixel to be on or off. The problem is, a lot of the brightness is still blocked by the filter. New technology lets us achieve additional brightness by allowing quantum dots to be engineered to produce a specific color of light. So what exactly are quantum dots? Here's what they look like to the naked eye. But let's zoom in closer. Here's how they look at the nanoscale. We can get these images by using a special instrument called a transmission electron microscope, which we see here. These quantum dots are actually just very, very tiny clusters of atoms. To give you an idea about the size of these quantum dots, each one is roughly 100,000 times smaller than an ant, which itself is about 100,000 times smaller than a football field. Wow! The super small size of these quantum dots lets us see some very interesting effects when light is shown on them. Different sized particles glow brightly in different colors. See how these seemingly normal vials of solution emit bright red and green light? So how do we make these quantum dots? It's actually very simple. Here is a flask containing a cadmium precursor, and then we inject a selenium reagent into it at very high temperatures. See how the color changes? That is the formation of cadmium selenide quantum dots. Then we can mix it with a polymer, drop the solution onto thin pieces of glass, let it dry, and get solid yet transparent films of quantum dots. See how they glow under UV light? They're also flexible and stretchable. What's even cooler is that we can make these quantum dots in different shapes, like rods, tetrapods, and plates. These different shapes will interact with light in different ways, as you can see when we rotate this filter. This filter is actually similar to the ones found in LCD TVs. And you can see how turning it changes the intensity. We can incorporate these quantum dot films into a TV structure to make them brighter and more efficient. Hopefully now you understand a bit more about the future of TV technology. Thanks for watching.